Okay, so now that we have OSPF set up, what we want to do is go in and set up our switches, put them into VLANs, split them apart. And what we're going to do later on is we're going to connect them back together through our router on a stick, and we'll put access control list on that router so that we can filter the traffic between the two VLANs. We're going to start here at Fremont. And to make this a little bit easier here, I'm going to call this one Fremont CA-SW1. And we'll call this one, whoops. We can do this a couple different places here. We can go to config here. Let's do Fremont CA-SW2, and we'll go ahead and close that out there, just so that I can go back and do this first one first here. So let's go to the command line here, and we'll do enable config T. We can do host name Fremont CA-SW1. And what we want to do here is we want to create two VLANs. So in this scenario, we're going to say that human resources has information that the other sales folks that work in this office shouldn't have. So we're going to create two VLANs. We can name these however we want to. But we're going to do VLAN 60, and I'm doing this because I'm using this particular number because these machines that are in VLAN 60 are going to have .60 in the third octet, and these other machines are going to have .62 in the third octet, and that's how I'm going to keep these separate. So we'll do VLAN 60. We're going to name that one HR for our human resource folks that have the secure information that we want to protect. We'll do VLAN 62 for the other sales folks, and we'll name that sales. And now we have two VLANs created. They are named, and we're going to go ahead and set some particular interfaces into those VLANs. And any computer that's attached to these particular ports will be in that VLAN. So let's do FA0/1. We've got a machine setting in there. We're going to go ahead and name this. We're going to go ahead and put this into VLAN 60. Now first we need to do switch port mode access. So this is a, it does have to spell correctly, switch port mode access. So this is a machine where, or this is a port where everything that's coming out of that port is going to be on VLAN 60. So any machine that you put, that you attach into this port is going to be in VLAN 60. And if it has the wrong IP address and it's attached to this VLAN, it's actually not going to function. And the other thing is that we're not really putting port security on, which is something that we might do later on, but we're not going to do in this particular scenario. You can set it up so that you know, if it's not in the right, if it doesn't have the right IP address, that it will get internet access but won't be able to access any of the important information. But we're not going to do that in this scenario. So this makes it a an access port, but it doesn't place it into the VLAN. To do that, we're going to do switch port access VLAN 60. And then let's do our 0/2 and we're going to do switch port mode access, and we're going to do switch port access VLAN 62 for this one. So these two ports that we have here are going to be in VLAN 60 and in 62 respectively. Now you could go ahead and create another two ports that were also in 60 and 62 respectively, connect two cables from this switch over to this switch and send that traffic across separately. And then we would have things over here that's on VLAN 60 and VLAN 62, and then, you know, that would work. But, you know, if we have 20 VLANs on this switch, then we don't really want to put 20 cables across. We don't actually have that many cables. So what we want to do is we want to create this connection going across here, and this one here need to be trunk ports. Transfer multiple VLAN tagged packets or frames, actually, since this is frames going across the trunk port, can be tagged with lots of different VLAN tags. Okay, so now let's go ahead and do this. We've connected to gigabit 0. Whoops, G0/1, and we'll just do switch port mode trunk, and you'll notice that the status goes down and then back up. And next we're going to do G0/2, and this needs to be set switch port mode trunk as well. Okay, let's do a do copy run start, and we'll do a show run here. Do show run. And now you see that we've got switch port access VLAN 60 for port number 1, 62 for port 2, and then we've got the trunk mode set on our 2 gigabit interfaces. You'll also notice here that, you know, when we did this, that this router here, this switch here, kind of lost connectivity because it can't really connect into that trunk until we actually do the trunk on that side. And that's what we're going to do next here. So let's go over to this particular switch. And this one is going to be switch 2. So let's do host name Fremont CA-SW2. And we'll do the same sort of configuration here. We'll do VLAN 60. Name HR. VLAN 62. Name sales. Interface FA. (0/2), and this one is switch port mode access, and this one is VLAN 60. And is that right? Do I want to put? I don't. Port 2 should be in VLAN 62. I'm not sure why I did port 2 before port 1. Doesn't really make sense, does it? So let's do FA01. We can do switch port mode access, and it needs to be in 60. Okay, sorry that that's kind of a little bit backwards there. Okay, so now we only have 1 gigabit interface. I think this is what I was looking at when I was looking over at the thing here. I was looking at gig 02, and let's do 0/2, and this is going to be switch port mode trunk. We don't have a G0/1 in this scenario. Okay, so now we should be able to do a do copy run start, and that should do it for this particular switch. Now let's go ahead and put IP addresses on these particular machines. And to do that, we're going to go to the desktop, and we'll do IP configuration. And so we're on our fast Ethernet here. So we'll do our address here needs to be what does it need to be? 170.32.60. something. I do not have my diagram out. I should check that before I move on. Okay, so it looks like this one is 170.32.60.2. Subnet mask is actually 255.255.255.0. This is a naturally a B address, but we're subnetting it down to a C size. And then we have 170.32.60.1 is the IP address of the first router that we would come to when we leave this network. So this is our default gateway address. Okay, so that configuration there should be fine, and then we can actually go ahead and close right here. We can go to the command prompt here, and we'll do IP config, and that will show us that our IP address is 60.2 with a default gateway of 60.1. And we always want to double check 170.32.60.1 that we can actually get to our default gateway. And we can't. So why can't we here? So we're in port 1. Oh, yeah, we haven't actually configured our router up here yet. This is where the 60.1 is going to sit, so that's not going to work just yet. So we have our trunk port across here, so we should be able to configure this one, and it is going to be 170.32.60.3, I think. got to be very careful to change that subnet mask. And again, our default gateway is going to be 170.32.60.1. And it would help if I didn't put an extra dot in there. 170.32.60.1. Okay, now let's see if we can, we'll do IP config. And let's try to ping 170.32.60.2. And that should work, because we have a trunk. These are both in the same VLAN. Now I'm going to click on this one here. We'll go ahead and we'll put IP configuration on this one. This should be 170.32.62.2. And then 170.32.62.1 is going to be our default gateway. And command prompt, we will IP config. Always just to kind of double check that. Now, let's try pinging 170.32.60.2. That's a machine that's right here, and you should not be able to ping that. When you create VLANs, you're actually splitting this apart as if these were just like two switches that were not connected to each other at all. But let's go over and do this one. We'll go to desktop, IP configuration, 170.32.62.3. Be sure to change the subnet mask. 170.32.62.1 is going to be the gateway. IP config. Let's see if we can ping 170.32.62.2, and that should work. Okay, so what we have now is we have 4 PCs here existing in 2 VLANs, and the 2 VLANs, or the 2 computers that are connected to VLAN 60 can ping each other. The 2 PCs that are part of VLAN 62 can ping each other, but they cannot ping across the VLAN, and they can't until we actually modify the configuration of this router over here, and we call that a router on a stick. Now, we've integrated this into our configuration here, but sometimes you will actually have just a router that's sort of sitting out here by itself, not connected to anything other than to the switch, and its function is to do this router on a switch, router on a stick functionality. This inter-VLAN routing is the more correct term to call it, but Cisco guys call it router on a stick. So, and Cisco gals. Next, we want to go ahead and look at our configuration here really quickly, because it's been a little while since I've done this particular device here. So we have OSPF, and the interface that's connecting down to the switch here is FA0/1, and that's this one here. We have no IP address configured on it. If we did have an IP address on it for some reason, you can't have subinterfaces and physical interfaces both having IP addresses on them. So let's do config T. Whoops. Config T. And we'll do int fa0/1. And I'm going to call it .60. Now, you don't have to call these, like there's no, connection here other than keeping it in your mind. As far as naming it .60, you could just as easily name it .1 or .2 or whatever. But I like to keep it so that I can know that when I'm dealing with this interface that, what the IP address is. So I can make some kind of relationship between the VLAN and, like the third octet of the IP address and the subinterface numbers. Those things really make it easier to keep track of this. So we'll do an IP address of this on the 60 VLAN. We're going to do 170.32.60.1, 255.255.255.0. Oh, it would help if I actually type 0 instead of O. Actually, I need to do the encapsulation thing first, so let's do that. We'll do encapsulation .1q, and we're going to put this into VLAN 60. So encapsulation .1q 60. We'll put this into the appropriate VLAN. So there's two types of VLAN encapsulation. Interswitch link is a Cisco proprietary, and that's what you see this message here about. And then the IEEE standard is 802.1q, and so that's what we're going to use on this one here. So we'll do the .1q first, and then I can go ahead and put the address on, and then that will function. Now, I'm not going to worry about doing a no shut here. You might have noticed that the state changed to up previously when we created the sub interface. That kind of works, but we're going to actually use the no shut on the physical interface after we've configured the two logical interfaces off of it. So the other thing that we want to do here is .62. So int fa0/1.62. And let's do the encapsulation and put it in VLAN 62. And I know I'm really lazy with typing here. I love the up arrow functionality. So that gets all of our two sub interfaces done, and then we can do int fa0/1, the physical thing, and then we'll do a no shut here. Now it probably won't indicate this that it actually has brought it up, but that's just always a sort of a double check thing. And then next we wanted to go to router OSPF. I think our number was 100. Our process ID, and we want to add in network 170.32.60.0, and obviously these are all still in area 0, and then we need 62 to be added as well. And I want to do copy, run, start. Okay, so what we had to do is we have two new interfaces, and so anytime we add an interface, we also have to add that into our routing protocol. Otherwise, these networks are unreachable. So now, if we go back here and we ping our gateway address, that should work. Let's ping the gateway of the other VLAN, and let's ping a device that is in the other VLAN, and it takes just a second to get that because it's actually has to go all the way up here to the router and then come back down to here, and we should be able to get this one over here that's in the other VLAN as well. Okay, so that's VLAN configuration and inter-VLAN configuration, as well as setting up our PCs on this topology.